remember that.
Yeah.
All right, everybody. So yesterday we talked about, started talking about deep bed systems, specifically vertical flows, and then into radial flow, which is actually a horizontal flow. And today we're going to move into strict horizontal flow design, which is more sophisticated but offers more options for things. So, big red magic marker. I brought it in my desk. Oh, yeah, there it is. So, so we have two systems called, one's called the packed bed scrubber, the PBS, and one's called the VTS, which are for horizontal flow. And we're going to concentrate on the design of the PBS because understanding the principles behind this all translate to the VTS, vertical transition system as well. So a typical design for a PBS system is something like this.
I'll just send that to him.
All right, so just the basics of this is that a PBS has a horizontal flow design. If we're using it in an odor controls application, we're typically going to put a mist and grease filter at the inlet, and then we'll actually have some plenum space that allows the air to spread out. And then there are going to be sheets of some type of a screen. So we're going to have like a fiberglass grating here, or some type of a structure, and it's going to have a screen in there so that the adsorbent media can be put in this section and not fall through the grating, through the structural part, okay? So we're going to have a structural with a grating, with a screen here, structural with a screen here, and a structural with a screen here. We're typically, and this is typically, going to have a 24-inch deep bed of one particular type of media, and then it's going to be followed with a 12-inch deep bed of another media, okay? So the general principle behind especially odor control is that in municipal odor control for sewage is that there are lots and lots of different types of odors in sewage. The primary one is hydrogen sulfide, okay? And so we're going to first use an adsorbent media which has a very high capacity for hydrogen sulfide, and because that's the primary odor, it has the most constituent. It's usually 90% of the odor is one particular gas, hydrogen sulfide. So we're going to use one product that's going to capture the hydrogen sulfide. In this case, and we're not really talking about adsorbents right now, but I'll just mention it's usually Sulfazorb XL, which is fantastic for removing hydrogen sulfide. And then we'll end up having a polishing bed here. So we might call this a roughing bed and this a polishing bed, okay? So, and then we use, typically in this area, we're going to use a product called CPS 12 blend. We used to use CPS blend, but we kind of upgraded to CPS 12 blend there. And that CPS 12 blend is a blend of plain activated carbon and 12% pure air 12 media, which is 12% permanganate on aluminum, okay? So that combined combined, two medias combined in there is kind of a shotgun effect, right? Just capture everything else that comes through, all right? So that's how we would typically, and then we're typically going to work on some type of a draw-through blower. So it's either going to be a plenum fan that's inside the housing, or it even could be a external blower that's pulling air outside, okay? There's different advantages for inside and outside blowers, and we can talk about that in a little while as well. So this is a typical odor control design. So why is it that we have this small mist and grease filter here, and then we have this big section for the adsorbent media? Well, the key is, I think I mentioned to you yesterday, that airflow through the media can be at various rates. But the key is that the pressure drop, there's kind of a maximum pressure drop through a deep bed of adsorbent media, and it's basically 100 feet per minute. Okay, so this airflow is typically anywhere from 50 to 100 feet per minute of velocity. We typically go with 50 because it has the lowest pressure drop. If the air goes through the media slower, then it has a lower pressure drop, and also it gives more time for the air to react inside the media. So if the air goes through the media slower, then it has more what's called residence time. It's also called empty bed residence time. So air going slower through the media means more time to react and capture those odors. So again, for odor control, we typically go around 50. We can push 75. We typically don't go, we try to stay away from 100 for odor control. Right, so we'll continue to talk about the odor control design primarily. Now for odor control, also for the PBS, the material constructions is typically going to be fiberglass, FRP, fiberglass. Okay, because it is resistant to corrosion. Now we're also going to have a whole nother session talking about materials of construction for all of the different systems, and we're going to kind of outline which materials we can use for which product and why, because there's good technical and there's good commercial reasons for choosing different materials, okay? So you guys being the technical guys certainly need to understand the technical aspects, but then on the other hand, you know, we can make everything out of platinum as well, but we'd never be able to sell it. So we have to be careful about that. So the key is this mist and grease filter operates at a much different airflow rate, okay? Then we send the air through the media. So the airflow rate for this mist and grease filter typically needs to be basically 300 to 350 feet per minute, okay? Much faster than we're sending the air through here, okay? Now keep in mind, we target for 50, but you could go down to 20 feet per minute if you wanted to on the media, okay? But there's actually a lower limit that we don't want to go too much below here because of the mist and grease filter. So here's how a mist and grease filter works. It works off of two principles. For mist, so you guys, have you guys all seen our mist and grease filter? It's like a Brillo pad kind of type thing, right? Okay, so we have this mist and grease filter pad, which has 3 layers in it. Okay, so these outside 2 layers are the exact same thing. They're basically a stainless steel, 3/16 stainless steel Brillo pad, basically. And then on the inside, we have these polyfiber fibers on the inside. So the way that a mist and grease, let's just talk about, it's a mist and grease filter because this is for the mist, okay? The outside ones are for mist, and the inside is for grease. I hope I have that right, but I think I do. Okay, so let's talk about how a mist filter works. A mist filter, and we're gonna magnify the mist filter all of a sudden, and we're gonna start taking a look at each of the individual little stainless steel fibers. Okay, and here's a droplet of water, a droplet of our mist. Okay, so this is super magnified. The droplet, if you go too slow, so this is basically, if you think about this droplet, it's basically fog. Okay, that's the size droplet that we're talking about, right? You can't really see it with your eyeball, but you can see a bunch of them together. With it. As this mist droplet goes through here, if it goes through too slowly, it'll just weave around these stainless steel fibers and make its way through. Okay, so the principle of how a mist filter works is you've got it's called impingement. You've got to make sure that that mist droplet runs into a fiber here and bangs into it. And when it bangs into it, water is sticky, basically, and sticks to the fiber. And then another one comes along and it sticks on there. And finally it makes a larger droplet, and they drain down the fibers. And there's a drain at the bottom of the mist filter housing, and the water comes out. Okay? So that's how the mist filter works. It's kind of on the principle of impingement, and it's basically collecting all those little fog droplets, and once they collect, then they get large enough to drip out of the system from that. So that's how impingement works. Now the grease, on the other hand, doesn't have any problem. The grease is just going to get stuck on these fibers in here, and so typically you're just using a different mesh which the grease easily bonds to in this mesh. So can anybody tell me why we have this? So if this is being used to collect the mist, and this is being used to correct the grease, why do we have this layer on the back side? Why do we also have a mist filter on the back side of the filter?
For a mist that gets through the first layer?
That would be the most obvious thing, that you would think that would be the case, but the reality is a lot more practical. It's so that the customer can't put it in the wrong direction. Okay? It is purely just to make it dummy proof. There is no technical reason for this right there at all. Sure, yeah, maybe it adds a little bit, but we catch a little mist that might happen to get through. But the reality is that mist would probably get caught up in here, probably. But so it's just, because if we gave the customer just this, half the time he'd put it in backwards, right?
And the phone calls you get, which way?
It's not working and all that stuff.
So you have to have the mist before the grease?
So I think in general, I'm not sure about that, but in general I think so. I think because you don't want the center pad having to take out both mist and grease, it probably just kind of clogs it up, kind of type stuff, I guess. Yeah. So that's the principle. Now I'll also mention to you, this thing is not easy to clean, to get the grease out of. These are super fine fibers in there, and when you guys go out for startup, you really need to talk to the customer, and we really need to update the O&M about how to clean this thing. And the way to clean this is, first you take the pad out, and the customer should always order a spare set of pads. We don't give them to them for free, but a lot of times in the project specs they'll order an extra pad, or after the project they'll ask for an extra pad. But they should take the pad out, and they should stick it in some kind of a basin, some kind of a trough, with hot water with a degreaser in it, like Simple Green. Simple Green is a good, very available degreaser. And you let that thing soak in there overnight, because all this grease in here. So where's this grease coming from? Well, it's coming from the Mexican restaurant up the road and whatever else, right? I mean, this is sewage, guys. It's got whatever in there, right? So this is the nastiness here that's getting in, dirt and grease and whatever, okay? So you put that in the basin, and you let that simple green get in there to work on all these particles, okay? But even at that, you're not really going to drive that dirt out because there's dirt and grease in there. Afterwards, you've got to go in with a pressure washer and really hit this thing hard and wash that mist and grease filter out. So hopefully it'd be nice if you could do it with hot water. One of the best ways that I've done with a customer, I took one to a car wash, a manual car wash, and just went in there, and when you hit that thing, you'll see all the real nasty dirt coming out, and then you just do it until the water turns clear from it. So anyway, that's kind of a little sidestep on mist and grease filters. But because we're running the air through there at 300 to 350 feet per minute, we need a much smaller filter. The area of this filter needs to be much smaller than the area of the media bed, okay? And that way, we have the same airflow going through here, but at different velocities, all right? So that's what happens there. Now, well, we'll get through this, and then I'll also talk about the design for not odor control, but for industrial electronics, because it's going to be a little different. So the air comes through, but keep in mind the air has to spread out. All right. So if the air is coming through here at 300 to 350 feet per minute, if you're not careful and you just, let's say you didn't have a very you didn't have a large plenum space. So this air area here is called a plenum space. Then that air is just going to be blowing up against the media here, and it's going to just keep trying to blow through this area, and hardly any of it's going to get down here. Okay. So the typical rule of thumb is that you want the maximum point here to, here, I gotta fix this, hold on just a second, to the maximum, so the highest point of the media, of the mist and grease filter area, and the highest point to the carbon bed to be about 45 degrees, okay? Again, that's rule of thumb-ish. If it was 50 degrees, or whatever, it's not that big a deal, but that gives you an idea of what we typically have to allow for the air to spread out. Okay, and there's actually standards for this called SMACNA, SMACNA, and that's basically the people who make sheet metal and something, whatever. But these are basically the guys that who control the design of ductwork. All right, and they basically say, well, you should use 45-degree angles here, and you should use 30-degree angles and stuff like that. So now keep in mind, it's not from the center of the mist and grease filter up here. It's from the upper edge here, and then from, of course, the lower edge as well. All right. So we would prefer to see this centered, see the mist and grease filter centered, so that you can get an even 45 and then another 45. Sometimes the customer wants to give you a specific inlet height, so we have to kind of work around that with it. But if he doesn't, then we want this thing centered on the media bed for there. Okay. So the air is going to come in. It's going to go through this screen. It's going to go through this adsorbent media. It's going to go through this screen. It's going to go through this adsorbent media. And then we have to do kind of the same thing on the reverse side, right? We've got to, well, so it depends. If you've got an external blower, then you need to allow for that same kind of 45 that's coming in so that the air is flowing well in there, okay? So if we have an internal blower, it gets a little more complicated from an airflow standpoint. All right, so an internal blower is typically what we call a plenum fan, okay? And a plenum fan is just going to be a fan that's in here like this. It's got this blower wheel and a shaft and a motor on it, okay? And basically we have to have an additional wall here to connect this plenum fan to, and then there's a hole in this wall, okay, which, so this is, you know, for like RG, that plenum fan that you're using, you're doing on,
Bass Museum.
yeah, Bass Museum, right?
Yeah.
Or anyway, so that's it. So we have to have a plenum space here for the air to go through. Again, this is going to be kind of from the bottom to the hole, the opening of the hole in the wall, like this. Okay, this is a lot harder to maintain the 45-degree angle here because it depends on the bigger the system, then the more room you get. So usually this is a little more kind of more like 30 degrees or something like that with it. Okay, you just can't have this fan right up against the screen. You got to be able to get some air to flow down like that. Okay, and then this is going to be so this area is going to be under vacuum because it's pulling the air through. This area is going to be under pressure, and then typically we're going to have either, you know, a vent back here, or maybe there's going to be a chimney on top, and the air is just going to collect in this plenum and either go out or go out one way or the other. Okay, so why would we want to do one or the other? Okay, well, the advantage of this type is that it's typically a lot less it's a lot more quiet. We've made some super quiet systems using a plenum fan that are really nice, because one of the things that you can do is you can even put sound insulation inside of this housing, which makes it really nice. Okay, the other is a plenum fan is typically a lot less expensive than an external blower. Okay, because in odor control, the external blowers typically have to be fiberglass, and they're typically fairly expensive blowers. So this blower is more expensive. The other is that these plenum fans are typically, not always, but typically direct drive. And so this allows you to easily attach a variable frequency drive or a speed control to that fan in order to change the airflow. Because, all right, so this engineer said that he wants 1,000 CFM, but you get it out to the field and it turns out, oh, we actually need 900 CFM or 1100 CFM, and it's very easy just to make that adjustment in a speed control. It's very cheap to do that as well. So this is a very nice feature for that. Now, one of the disadvantages, now the whole unit has to be bigger to allow for this plenum section, and so the fiberglass portion, the fiberglass housing is now more expensive. Okay, so there's a little bit of trade-off. And, you know, we just kind of have to get through it and see which, you know, the sales guys are typically going to be working on the design up front, and then they're going to be deciding whether we want an internal plenum fan or external from that.
Anytime you have a plenum fan like that, you need to make sure that you order a cone that goes along with it.
Presentations.
So if you're looking at that, there needs to be a plastic cone that wheel is going to basically go into.
Oh,
It's mounted to the back
Cool.
side of that wall.
okay.
Yeah, so where you got the fan, where you have the fan at right there, there's a cone
Okay.
that actually inserts into that and goes against that wall.
Yeah, I'll check with Sergey. Okay. All right,
Make sure
thanks.
you know that, so when you're ordering your TDK wheels, you get those cones.
Yeah, so I missed what you were saying.
I was talking about cones, the reason why you want to order a cone with the TEK wheel.
Right. They're they come together. I don't know why they even sell them separately. It's kind of dumb. You got to have the cone with the wheel, but anyway. So yeah, you got to have a cone and wheel there. And another weird thing about TEK is they have clockwise and counterclockwise wheels, and it's kind of like, so you call them and you say, give me a counterclockwise TEK 250, and they say, I'm sorry, we're out of stock, sorry. And they won't come and say, well, we have a clockwise one, right? Or, you know, and for us, who cares whether it's clockwise or counterclockwise? The motor turns both directions, right? We just need to know which direction it's going to turn. So I think our standard is typically counterclockwise. So just remember that in the future when they come up and say, sorry, we're out of stock. You can say, well, how about that other part number right next to that has with it? Because they're really bad about giving you that option.
How big is that actual space where the motor is in?
So this is usually maybe kind of 3 feet
Okay.
And there, it depends on the size of the system.
Yeah.
Smaller system, it might be just 2 feet.
And
With
how,
it?
how do you get,
'Cause-
how do you get to the motor? How do you?
So, oh, and there's gonna be a door on the side of the unit here.
Okay.
And this whole door is gonna open up, and then you can kind of, if it's a big enough unit, you can walk in there with it, kind of type thing with it. So, but keep in mind when you're designing the system, this door here is gonna be under pressure, right? So the entire system is under vacuum, right? Because you're pulling the air through. So this is under vacuum. So the door for the mist and grease filter kind of will keep itself shut because it's under vacuum, right? So you don't have to worry so much about making it super airtight or anything. It's gonna kind of, you know, keep itself pulled shut. We should make sure we're making it nice and tight, but, all right. And everything here is under vacuum, but this one's under pressure, right? So you put a door on there, especially if you put a big door on there, suddenly now you've got some pressure. Now it's not a tremendous amount of pressure because you're pretty much just exhausting out this chimney here, but there's some pressure there. So you need to allow for that in that door. You need to have a really secure way of, you know, latching that door kind of all around in a number of different spots. Make sure that the door is nice and rigid with it as well too. So Christmas time. Thank you. Okay, so that is so that's kind of general PBS design. But what I want to talk about up here is the Fill-Chute. So I'm going to erase all this, and we're going to talk about Fill-Chute because that is probably the most critical part of the design of a horizontal flow PBS or VTS or actually radio flow unit here is the Fill-Chute design. So making this a little bit larger, this is plenum, this is media type 1, this is media type 2. Okay, so in the top of these systems is this area called a Fill-Chute. Okay, so a Fill-Chute is literally, we've got a lid on top of this system, and in order to fill the system, you take off this lid and you dump the adsorbent media into these 2 different compartments. We have bulk sacks for really large systems, and we have cubic foot boxes as for smaller systems, okay? And you literally open it and it pours in here and it starts to fill up, okay? And so the question is, why do we have this Fill-Chute if the air is only coming to right here, okay? This is the top of the screen right here, and this is the actual outside of the unit. Why do we have this excess media? It's kind of wasted media if you think about it, because the air is just going to travel across, okay? Well, we have the Fill-Chute in here to allow for media settling and to take care of bypass, okay? So the first is our media has this, or any type of kind of granular product has the characteristic that when you fill it, over time it's going to settle, all right? Just like, what's a good analogy about settling something? I can't think of a good analogy about
Popcorn.
popcorn, okay? Yeah, so, what's that?
Coffee grounds.
Or coffee grounds, yeah, anything, so you fill something up, and especially if it vibrates a little bit, which, you know, this system is going to vibrate a little bit, anything's going to kind of settle over time. Let's just say sand, right? So you take sand, you're at the beach, and you put sand in a bucket, and you shake it around a little bit, and that sand levels out, and well, the same thing's going to happen here. So we get the contractor who's installing this system, and we tell them, make sure to fill this thing to this level here. All the time, they want to fill it to this level here. 1, because it's less work, and 2, because they think that because the screen's here, they only need to fill here. And we have to tell them all the time, no, fill it all the way to the top of the Fill-Chute. Even if you tell them, fill it to the top, they'll think this is the top.
Yeah, I know.
Okay? It's the most frustrating thing. Fill it to the top of the Fill-Chute, almost so it's about to overflow. Okay? And then, you know, you think it even, I've done it, I've been on top of you, and I've put my foot on it and kind of stamped it down kind of to try to make it settle a bit. and really try to get it packed in here. Okay, and here's, so we have this kind of overfilling area to allow that if it does settle, then maybe it settles to this level and doesn't get below here. Okay, so that's all fine and good. But now the question is, how big does that fill chute need to be? Okay, so let's take a look at this. Air follows the path of least resistance. Okay, if you have a 1-inch opening here, let's just say that the screen just goes to right here too. Okay, and this fill chute is kind of an open area. If you've got a 1-inch settling in the media, here's what's going to happen. The air is going to come in here, and it's going to choose the path of least resistance. Okay, so what's the resistance to travel here? Well, it's the resistance of 36 inches of media. Okay, we'll talk about calculating resistance and things like that here. Okay, but hey, that air is kind of smart stuff, right? Says, hey, I got an idea how to take a shortcut. Let's just go up this 12 inches, right? So if we have a 12-inch chute, and then let's shoot down the expressway here, right? And then take this side street down here, and look, all I had to do is go 24 inches. Okay? And it's all, and that's, and now it's super happy. It only had to go 24 inches instead of 36, kind of type thing. 24 inches of media to do that. So that's a concern for deep bed systems that we have to be really careful of. So how do we prevent that? Well, one of the best ways of preventing it is, one, make sure your fill chute is high enough. Okay, and usually 12 inches is more than enough. Okay, but the way that you make sure that 12 inches is enough is that you make sure that this wall here above this screen, so keep in mind this is going to be a porous screen here that air flows through, but you make this a solid wall. So this is a baffle, we call it, okay? And you make sure that this goes all the way to the top and that this lid comes in contact with that, and that you put some gasket there to make sure it completely seals, right? So now if you've got a 1-inch gap, what does the air want to do? It says, all right, I'm going to go up here, I'm going to try to cheat, I'm going to go up through 12 inches, and then I'm going to run, oop, boom, I ran into this. Now how do I get out of here? Well, the only way I could go down is to go through here, add another 12 inches, go back around, come back up, that's another 12 inches, go back down and go back around. There you go, that's 48 inches now, right? It's going to say, oh, that doesn't make sense. My GPS is telling me to do this, right? So that's how we prevent that. This simple device here basically completely eliminates the need, any kind of bypass here. As long as you've got a decent amount of media in this area, even with a little settling, this baffle will take care of that. Okay? Very, very important for any type of a deep bed system, VTS, PBS, and an RF, because an RF has the same type of fill chute on top.
What is the baffle attached to?
So the baffle can't attach to this screen. So this is going to be this grating here, and it's going to be on top of this.
It sits on it?
And well, it's actually going to, so it is going to sit on it, but it's going to be attached to the two sides of the fill chute as well.
So when you open it, it comes out?
No, it stays in here. Not to the fill chute lid, but to the side of the unit itself. Okay.
So fiberglassed in, basically.
Yeah. So looking down at the unit, right? This is the fill chute here. The baffle is attached to the sides here, and then it's also attached here. And if it's made by fiberglass, it's very easy for them to make all those attachments. And
is it fiberglass? The baffle's fiberglass also?
Typically the same material that the housing is, yes. So if we made one out of stainless steel, then the baffle would be stainless steel as well. Super, super, super important. We've got a big issue going on in Washington, D.C. right now with a competitor system. And the competitor, I'm going to draw what the competitor did for his baffle. And this competitor ECS actually convinced the customer that there was a problem with our media rather than his system based and on his design. So his baffle, he uses an internal baffle. Okay, so if the system is like this, he does his little Fill-Chute, not a very high Fill-Chute at all. Okay, but he uses an internal baffle coming down here. Okay, so this is plenum.
So before it even gets to the media.
Yeah, airflow coming in here. Okay, so and then he has a screen here. Let's call this. I'm going to make this screen here. Okay, so he has a solid plate, and then he has a solid plate. This is like 18 inches. Okay, and then he's got screen here. Oh no, I'm sorry. That's not. He doesn't have a baffle here. He just has screen here. I'm sorry. No, maybe he does. Let's just say he does. I don't know for sure, but I think he's got a solid baffle here. Okay, so solid, and then he's got the same thing here. Solid baffle.
Wow.
Okay. Okay. And they don't fill the Fill-Chute at all. They tell the customer, you don't have to worry about filling the Fill-Chute because we've got a baffle down here. Okay? So the customer, so first of all, what happens in this system? First, the air never gets here, right? The baffle, the air, the first place the air enters is this area. So you get very poor usage of any of this media here. But the reality is, I'm going to explain one thing here to you. It's called the wall effect when you're talking about airflow, right? So the air will actually, because this is a smooth surface here, so this point where the media comes in contact with this smooth plate is actually a place for air to travel up a little bit easier. Just a little bit of airflow can travel up very easily up through here, okay? And then the rest of the air is going to start, so if it comes in here, this competitor is expecting that the air is just going to flow straight across and go out like that, okay? But that's not going to happen. So what's going to happen is, because this is an open airspace, okay, that air is going to start to, well, some of it is first of all going to travel up the wall, okay, because remember you've got 36 inches deep here, and this is only 18 inches, and then this is only 18 inches, so it's kind of the same route, okay. Okay, so some of it is actually, it's actually going to be a quicker route because the pressure drop right along the wall here is a little bit less. So you're going to travel this 18 inches and then travel this 18 inches a little bit faster, a little bit easier than you're going to travel the whole 36 inches, okay? So you get some leaking there. And then what also happens is, you guys ever done one of those games where you drop something at the top and it kind of bounces around? Planko, yeah, Planko, right? And it drops in, it bounces around, and some of them land over here, and some of them land in the middle, and some of them land over here, okay? Well, that's what is happening with the air in here. The air is hitting here, it's hitting one pellet, one little pellet of media, and it has to decide, do I go right or do I go left, right? Okay, so this one decides, all right, I'm going to go right, and then this one says I'm going to go left. Well, then it has to hit one of the pellets here. Where do I go right? Do I go right or do I go left? Okay, so the media, so the air is going to eventually, naturally, head in this direction. Okay, even, you know, so you're going to get no usage of this media here at all, and you're going to get some usage of this media. Now, here's the problem: is this air starts to come out. Okay. So it travels through this bed of adsorbent media, okay? So if this is for H2S, then it travels through and it takes all the H2S out of it and it does a good job, okay? But what happens when it gets here? Okay? Well, now I can just jump over and head back down. So it's doing some leaking in that case. Okay? And so how could this competitor have prevented this from happening? Well, if he would have had a solid baffle right here and filled the media all the way up in this Fill-Chute, then now the distance to travel all the way up here and all the way down and then back down and around, there wouldn't be any kind of leaking at all. Okay? So how we found out about this issue is the customer put only our media in this section here. He wanted to take out just, they were having a problem polishing the odors. They were doing a great job of taking out hydrogen sulfide, but they weren't doing a good job of taking out some other gases, specifically one called dimethyl disulfide. And they tried our media in a test rig, and it worked really, really well. Then they put it in this system, and the system kept taking out the hydrogen sulfide, but it kept letting some dimethyl disulfide get out. Not a lot, but enough that they were unhappy with it. And they blamed it on the absorbent media, when clearly it's a design issue, it's an airflow issue. And why doesn't this competitor know about this? Because they're fiberglass guys, they're not airflow guys. Okay? They make a beautiful fiberglass system, but they don't know how to operate it. They don't know, they didn't even know, and really, even if their Fill-Chute was filled up all the way here, it probably would have prevented the problem as well. But certainly having a baffle and filling the Fill-Chute all the way to the top would have completely taken out the problem. So, a month after installing this media, a huge order, I think, what was the value on that order? Like $15,000 worth of media. A month after putting on our media, they decided they didn't like it, so they took it out and put something else in. And the media was basically brand new with it.
But did
And the other thing was, if you look at the way that's happening right there, at the back half where our media was, it's only used in that very upper section. Most of the load is all coming up there and just a little part of the triangles is coming right out. So let me share. So this is like, when this shoots straight across here like this, and it comes down here, there's our media load right there. So it's like it's using that much of our media, and if I had to throw some number on it, I'd say like maybe 50% is going there, and the other 50% is all just kind of dwindling all down through here.
Sure, yeah. So you've got some odor being captured in here, but you've got some odor that is, and because of this wall effect here too, even if there is a baffle here, some of the odor is going just straight out.
Yeah.
Okay, so it's, anyway, so this is a big issue I'm dealing with at the moment because it's Washington DC, and they think that it's our product that's the problem, and even though we've explained it to them, they don't want to believe this stuff. So I'm going to go up there in a few weeks and basically do the same presentation for them to show them why it's a problem. Hopefully a little more professional drawing, but we'll see. So that's Fill-Chute design. Very, 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 very important for these units. And it's very important that we tell the client, the contractor who's installing this, like 2 weeks after you fill this unit, you need to go back and top the system off. Okay, document for them and everything, because when we get that call a month or two down the road and says, hey, your system's got odor coming out of it, we'll say, well, you remember when I told you, make sure to top off the media, and they go, oh, yeah.
Is that in our O&M manual? Do we want to put it in
I think
there?
it is in the O&M manual. It'd probably be worth double checking that. I'm pretty sure it is.
Okay.
when the media is replaced.
But they never read the O&M manual,
No,
right?
it's true.
It's gotta be in your training when you're doing the training.
The media gets replaced the same place you put it in originally?
So, yeah, in a PBS unit, so we've got the Fill-Chute on top. Most customers will come in with a big vacuum hose and just vacuum out the media. But we do put on the side these Fill-Chutes for them to be able to hook up a vacuum truck and pull that out. The reality is, guys, nobody's using those vacuum attachments. We're probably wasting a lot of money on that. we could probably just put a flange port on there and not worry about the vacuum port, unless the spec calls for vacuum ports with it. So we have to be careful because our sales drawings still show the vacuum ports and things like that, so we just need to make sure, you know, if it's required, if it was in the sales drawing, we need to include it, but we ought to start taking it out of the sales
The
drawing.
vacuum port, is that a quick connect?
A quick disconnect, yeah.
Thank you.
You take off the quick disconnect, you hook up a 6-inch hose to it, and then you turn on the vacuum and it sucks the carbon out. Now, will it get all of that out? No, it's not gonna get all of it out. They're still gonna have to go through the top and get some out of the bottom. So if they're gonna do that, then they might as well just suck it out of the top, right? So, so it's really not a very, to be quite honest with you, I have never seen or known of a customer who used it. It's just one of those features that we offered out there in our desire to be customizable with it, but any of our competitors can do that as well. Okay, so packed bed scrubber. So just as with the VBS system, you start running into issues when the tank gets so big in diameter that you can't ship it. The same thing will happen with a PBS system as well. So we're going to look at a PBS system now on the end of it, on the end of the PBS system. So this is the air going into the PBS unit. This is a slice cutway through. So this is